This is the monolithic story, how the circular economy enables open hardware. And so, let's hope, a little bit about me. No, let's not talk about me. Let's go and move on instead. So let me ask a question. What is the circular economy? Does anybody know what that is? Go ahead, Joyce.
Attempt to reuse hardware and other materials that go back into the economy rather than digging up new materials out of the earth.
Exactly, right. And you gave some good examples of the economy, circular economy. But yes, ultimately, as you would know since you're part of Endless, circular economy is about sustainability. It's about carbon footprints. It's also about cats. Okay, no, maybe it's not about cats. Sorry, cat. there's no, nothing like that. So, but here are some good examples of circular economy. So if you're the one everybody knows about is plastic bottles turning into something else. Whether there's some actually nice shoes, women's shoes that can be turned from there. That's become really popular as a brand. Shopping at thrift stores, secondhand stores, all those kinds of things are another great example of a circular economy. And finally, things that take raw materials that you find in the trash or something else and turn it into something else. So, wood or a piece of driftwood lying on the floor, or, well, not on the floor, but on a sand beach or something like that is another great thing. I saw a YouTube video of some guy who found something in these huge iron like from a shipyard or something, right? And he turned it into a sword, a Japanese sword. So those are really wonderful examples of how you could take something, turn it into something valuable, and resell it. But to put a more formal definition, it's really just taking raw materials and turning it into something else, right? As I just said before. And to kind of put it in scope, you don't want this. You don't want a place where you dump all your stuff. You really want to do this, where you're doing reuse. And that's the most important part of the circular economy, is to, as you were saying, is to take something and put it back and reuse them as much as possible, because we don't want waste. Every time we throw something away, we're actually paying a carbon cost. So how does that relate to data centers? Circular economy and data centers. Well, there's not much going on circular economy and data centers. There's actually only one primary company that is really looking at circular economy and the data center. So we actually have a lot of work to do in this space, because it is there's no players. There's really only one, and we got work to do. And we got to have angry cat feeling here, right? We've got stuff to do, and I think it's important. One of the things why I wanted to give this talk is to give that feeling of we have a duty to reuse as much as possible, and that there's actually tangible benefits of using the circular economy, which you'll find later in this talk. And why it's imperative is, I think if you wander around the talks in this conference, you can understand that we have a hunger for data. We want to collect data. We want we have Facebook, we have social media, we have cloud, we have on-prem clouds, we have off-prem clouds. We need and we hunger for data. We're really interested, and because of that, the demand for compute is high. So we're buying hyperscale class machines. We're having exponential growth in the data centers around the world. We can't get enough. Now, what do you think happens after that 4-year depreciation? They go into a dumpster or their landfill or something. What an incredible amount of waste, right? And so if you apply the circular economy to the data center, we're actually promoting reuse as much as possible instead of putting them in a landfill. And that reuse actually promotes low carbon footprint because we are actually deferring the carbon cost of manufacturing for all of them. So it's important. And if we don't, we want to defer as much of that as possible and make them useful for many lifetimes. Lowering that carbon means that it's great for our planet. We are addressing climate change because we're not manufacturing so much with that reuse. So it's good for humans, it's good for our nature and ecosystems, it's great for our planet. So I told you there was one player involved, and that's IT Renew. And this chart here kind of shows how that circular economy works. So IT Renew, what goes on there is they take supply, and that's Meta or Facebook, Dropbox, Google, all those things get sent to IT Renew, which decomposes those components, deposits them into their individual components. Once that happens, they get recertified. Sometimes they get sold back to the hyperscalers, but then there's this other interesting idea that came about, and that why can't we build servers ourselves instead of just selling it on the open market? And that's what was the cool idea about that, right? Because you can take those servers, recertify them, and then sell them to second-tier markets. Now, what are those second-tier markets? They're gaming, they're banks, they're well, I said financial institutions, whatever it is, right? Universities. There's so many governments. There's so many places, and we're giving these servers a second life, and possibly even a third life going on. So, and these servers are not some low-tier 20-year-old servers that one would think. They're the highest you can get, the best you can get at time 6 years ago. And now we can reuse them and send them out. The other great thing about it is uninterruptible supply of IT components. You know, this pandemic has taught us that supply chains are fragile, extremely fragile. And this is what is driving the cost of everything in the past 2 years. Now imagine having a supply chain that's local. So IT Renew has localized warehouses across different continents. So you're not shipping them overseas or anything. They're actually in Europe, they're actually in the US, they're in various other places. And so we're taking almost over 21,000 servers a month that gets incorporated and then and turned them into components. So that's pretty substantial supply to be used, right? And think of the other so you're getting them all, they're all localized. And I think that's a pretty powerful argument when, especially if you're a government, right? If you're getting it from your local thing, then you're not worried about any security issues because you're getting them locally. Okay, so I talked a little bit about the hardware supply. What else is interesting about it? So I think if you're going to rebuild and recertify servers, I think we have to change the paradigm in how we do that. Sure, we have existing standards, especially for racks or things like that, but we could do more. We could be more open. We could be doing more collaboration in this space. In fact, that collaboration is already happening. So we have standards, we need specifications, and most of all, we need a community. And we might need cats. Or maybe not. Maybe we don't need cats. What we need, though, and roll the drums, is the Open Compute Project. The Open Compute Project was actually started by Facebook. And it's a foundation dedicated to working together and building an open compute model across many parts. So in this way, the circular economy is joining a community of people who already are interested in an open specified data center. And I don't know how well you can see all these logos, but these are all people who are cooperating together. You have you have the hardware the ODMs, you have Facebook, you have the hyperscalers involved. And you have folks that are interested in networking, open networking. There is a wide variety of people working together in each of these parts. So it's a pretty amazing place. I've spent some time. I spent 2 years working with the Open Compute Project, and there's a lot of great things happening there. So here's the kind of benefits that OCP provides, right? You see things like high flexibility. One of the things we did at ITVNew was different form factors, right? We're actually all collaboratively designing together with different form factors that you can address. Let me give you a couple examples. Edge computing, right? You don't need huge servers, you actually need small ones. And there was this notion that you can put a data center anywhere, especially if there are small form factors. You can put them in underserved communities. You can use the output of those servers to heat homes. In fact, there's all these great things that we're talking about, like how do you reuse even the data center parts, the cooling, the exhaust. These are the kind of wonderful things that are happening in this data center space that most people don't know. The collaboration in this project is extremely impactful. We had one, I think there was one where we were taking the output of the data center and powering greenhouses. And so they were making marijuana. But anyway, they're a medical thing. But they went there and they used that, and it's like the output of this gave some kind of organic matter that it could be used, right? The same thing could be used for cooling or heating homes during the winter. So these are the kind of problems we're trying to tackle. In additional, we're looking at how do we improve cooling. So a lot of things we're doing in the Open Computer is how do we make dense racks, right? So once you're doing dense racks, then you're like, okay, how do we deal with the cooling issues? How do we do the heating issues? So all of these are collaboratively done here that we're all a part of, that we can rely on. So the engineering is not all done on one company, but it's geared across, it's spread across all of them. Now you're wondering, what makes all these companies work together like that, right? When there are competitors. It's because everybody's solving the same problem by themselves. What is the point of that? We're wasting engineering space, but we can't collaborate on the common problems together, and then our competitors can distinguish themselves on top of that bedrock, right? And that's why they work together, and that's why this project is so important, is precisely for that kind of thing. Okay, so let's talk about the monolink story, right? I don't know if this thing is going to play. I've been playing around. I'm sorry. Okay, so what is the monolith? It was it's a platform that was designed by Facebook and contributed to the Open Compute project in 2015. And it was designed for Facebook data centers for hyperscale workloads, right? And it's a pretty interesting platform. I will add, this is not the only platform Facebook has contributed. They've contributed several, at least 4 or 5, and the latest one is Delta Lake, which was just recently contributed November of last year. So what is it? So the monolith is actually a combination, right? There's something called Yosemite V1, and this is what you're seeing here. This is the enclosure, the design of the enclosure. There are 4 slots in the chassis, and each of those 4 slots contains system on a chip. And so each of them is 4 of them, right? And each of them is a Xeon D1500 series processor with up to 32 cores. And it comes with a BMC chip. The BMC chip actually talks to all 4 processors at the same time. And then each one of them has 128 gigs of memory. So with all of this, you're looking at one card about 128 cores, and 512 gigabytes of memory. That's a lot of firepower, and that's just one. And you can see a picture of that, what it looks like there. So imagine what 48 of them are. And 48 in a full rack, that's 192 discrete CPUs, not including the cores, right? And I think, I don't know about you all, but I'm pretty excited about what you can do with that. I mean, for a hyperscaler, I'm going to just do it this way. For a hyperscaler, this is nothing. But if you're a second-tier market, you should be drooling right now, because this is an incredible amount that you can get on one floor tile. And the best part is it's designed to be open from the beginning. This is not going to work out. Give me 1 second. Okay. That's what's great to be about an engineer. Thank you. Thank you. Thank you very much. I am an engineer, everybody. Okay. So anyway, going back to my point, it is designed to be open from the very beginning. And when this collaboration was actually between Facebook and Intel, and of course many others, and they wanted to build a hyperscale platform. And the collaboration is great, because I think, like for Intel is sort of the gatekeeper here in terms of a lot of the firmware and things like that. So, you know, to have Intel come to the table and work together on doing this kind of thing, it's sort of pretty awesome. Imagine all these how much we struggled for in the past trying to find open hardware. Of course, Raspberry Pi is a great example of an amazing thing, but you know, when you compare it to a monolith, it's pretty small in terms of as a computational unit, and it's great for a certain class to solve certain class of problems. But if you're trying to build large, wide, scalable solutions, then this is a great thing. And in the link here, you can see, if you're interested in seeing what the specifications are for the monolith, I have it here, and I'm happy to supply that to you. It's also available on their website. Okay, sorry. Now, where are we? But so far, I've told you nothing, right? What is the story? I think I I wish there was a way. So I'm a poor engineer now. Instead of- there is a mic, but can you turn it on?
Where the on button is. Can you help? Or, okay, just put this through your.
Here we go.
Does it work now? Hello. Okay, we're back.
Yeah.
Thank you. Okay, all right, we're back. And now a much simpler device rather than. Anyway, I'm not being specific. So the reason the slide is here is there is a story from before. We're just breaking it down because a lot of times it's about context. How do you know what's great? So if I didn't explain what the circular economy was, then you wouldn't know the context of the story or why this is important or anything else. If I didn't talk about the Open Compute project, you couldn't really understand how the work required to put this together. So, moving on. And I need my glasses because I can't see my slides. All right, so we got the specifications. We've got the hardware. We're ready to put some servers down. What's the problem? Well, okay. Remember when I said this hardware is old? It's 4 to 5 years old already. So what happens to old hardware?
Can't run new software.
I'm sorry?
Can't run new software.
Yeah. The other thing is, nobody wants to support it. Nobody cares. The lights have been turned off. They moved on to the new thing. The salespeople are like, oh, forget about that one. We got this really brand new one. You don't need 12 cores. Here's one for 34 cores. You don't need all that. But we're just a dental office. No. So the problem is that nobody wants to do support these new things, right? And that gets problematic. So if you're trying to sell somebody a server and it's running old stuff, and they ask you, well, what's the software updates? There's no software updates. What about security? Oh, there's not that much security updates. So that's a big drawback. And so if your BIOS is old, everything is old, so how do you fix that? How do you fix making these old hardware relevant going forward? You move to an open source tool chain. So that's the best thing, right? What's so great about the open source tool chain? It's community supported, and we can support it as long as somebody's interested in using those platforms. You can create an entire ecosystem just supporting that. And that's what's great. Once you get that going, we can support these servers in perpetuity. Now, some of the ODMs may not be happy because they want to sell you new hardware, but there are some who are always going to be cash strapped. Government, schools, all of them, they're like, we can't. And a lot of times there's an upper bound. I'm never going to need more than this, right? And if you're doing 21,000 servers, there is a lot out there. If something's broken, you can just replace them, and it's pretty cheap. And they're a fraction of the price. So I think that's a great part. And circularity, we need that openness, right? Otherwise, this model doesn't work. If we can't rely on open source and open specifications, this model does not really work to sell servers. And so we have to, so a lot of this is laying that groundwork to build sustainable platforms. Okay, so this part is really the work required to replace a tool chain. Looks kind of simple. Oh yeah, we'll just put core boot on there. It boots off Linux boot, and then, victory. It's not that simple. In fact, the engineering required to do this is extensive. Extensive. So it is not hard, and I think others, even for the newer platforms, there's so many pieces that has to align to make things work. It's actually easier for later models, but for models like the Mono Lake or the Leopard or some of these other OSPs, it is a pretty heavy lift to get them up to modern standards. But that's what I have to do to rely on it. So to enable core boot, you need an FSP, which is the firmware support package that comes from Intel. And it's the binary, we cannot avoid binary blobs. If you're using the x86 platform, and I think even ARM to some extent, there's a binary blob in there somewhere. And what is this binary blob? It's pretty much expresses the Intel platform and all its capabilities. The second thing is there's a BMC chip on there. Now there's a project called OpenBMC, and there's actually 2 OpenBMC projects, and one is run by Facebook, the other one by the Linux Foundation. And then finally, the kernel needs to recognize the hardware and actually boot. So that's the next stage of engineering to get this forward. So, a lot of engineering, right? So we actually had to hire a contractor and CISPRO Consulting to help us with this endeavor. And the great thing about them is they actually have a license to hack the FSP, which is few and far between. I don't think Intel is that forthright in giving license out to hack that. I think a lot of it is plausible deniability. If you hack it, they don't want to support anything that's hacked. And the other thing here is that where the FSP is. So the Mono Lake is actually FSP 1.0, and that is only supported by an older version of the core boot. So that's another bit of engineering. So 1.5 years go by of working. And so we solved the core boot plus FSP problem, and it was hard. A lot of tacos were involved. We forward ported the changes to the current core boot branch. So we took all the stuff that was in the older core boot branch, and then we forward ported them into the current one and upstreamed all that. And it was hard. It involved a lot of tacos and ice cream and martinis. Then finally, the kernel changes to the Yocto kernel, which I think is 4.0. It's the funniest thing about upstreaming changes to the kernel. A lot of companies do not want to directly contribute to the kernel. They rather do the Yocto kernel, because to get anything into the kernel, the mainstream kernel requires at least 1.5 years to get in there, because the first time you kind of contribute, you know you're going to screw up. Then the second time, there's going to be another set of things. The third time, finally you're getting around to shipping it, and then at last it goes in. Instead, you can go to the Yocto kernel, which has much more relaxed ways to get in there. So So a lot of times we end up using the Yocto kernel for embedded and various other things. And also more tacos. So, what was the end result of all that engineering? So the FSB now supports 8 cores. No, I'm sorry. It initially supported 8 cores and 16 threads, and then we doubled the resources and made them 16 cores and 32 threads. And so we made the FSP a lot more useful. So that's a pretty good tangible benefit. It still needs more work, but that's one improvement. So this is something the circular economy has helped enabled. We had to go and get Linux Boot to be able to support features that customers actually want. Otherwise, it's just a toy. So if you don't have iPixie, then that's not really useful on a hyperscale platform if you can't easily put operating systems on it. Let's see, what else do we got here? And then we had to support all the file systems on the storage. So if you can't get Extension 3 or 4 or ButterFS, not very useful because then you can't boot an OS on it. And then finally, we did actually manage to get booted to Ubuntu, and so that whole thing took about 1.5 years to get into a shape. And this is our family dog. He's celebrating. He's happy. We're all happy. But I can't underscore how much work this was. And it's not just the engineering work. It really required looking through the documentation on the platform, going through the FSP documentation that Intel provides, understanding all the data structures inside there. How do you expose, what data structures to expose to enable this feature X and feature Y, schematics, debugging tools, all the flashing software. Sometimes you screw up the thing and turn it into a brick, and then you got to figure out how to get it back off again. Then there's the kernel code. You got to look at the commit history. So everything, there's an incredible amount of work, and it's you got to keep going from one step after another. And so in the end, we did get something that we submitted to the Open System Firmware team at OCP. And so it was accepted into their repository in January 2022. And so we have a working system of sorts, but it's only one chapter 1, because there's still a lot of work to do. And so what's next? Well, it doesn't work with all distros. You got Ubuntu working. It doesn't work with free, like the BSDs. It doesn't work with Windows. So, you know, if you're following the process of core boot, UEFI, and Windows, maybe you don't care about Windows so much. But we do want to get all the other distros working, like Red RHEL and all that stuff. So we're going to need a lot of help from the community going forward. But there's a glitch. So IT Renew was actually acquired by another company, and the parent company was not really geared to selling products like we were doing, and they were more of a services company. So unfortunately, they had to dissolve the Sesame team that was doing the work. And but I think one of the great things, and this is where the resilience of having open source and open specifications, is that first we proved that this business model actually works. We have generated millions of dollars in profits in actually selling these hardware and doing it. So this is a concept that can work. and we have proven that it works. And so that's something we're really proud of. So a good idea never dies. And because these are assets that are freely under free licenses, we took everything, we extracted everything we did internally, put them on a GitHub, we put it on Notion.io. Nothing is lost. No, this endeavor continues to stay in the open, and that's great because even the customers who may have purchased our thing, they have access to all the information they need. So they can still go on self-support if they wanted to, or they can hire the former team that was working on it. In fact, my boss is doing another startup precisely. The way Sesame was created was actually as a client to IT Renew. So IT Renew's core business continues, but we were tapping into their supply chain to do our thing. So the only difference between what this new company does and what Sesame was doing was Sesame was part of the company. But there's nothing that says that you can't keep doing that just without that formality. So I think we're still in the game. We're still going to continue working on things like the Mono Lake and Yosemite V2 and all these other things. It just may take a little bit of time before we get our investors back in shape and being able to get back and do things. And besides, we have a planet to save. You know, we got carbon to save. We got to stop moving these things into a landfill. So you know, it's imperative that we do that. And there's so many other projects that this can key off, right? Again, going back to those form factors, going into underserved communities, building data centers that can be functionally part of communities, because one of the interesting challenges, I'm sorry, I'm going on a tangent, is that like if you're trying to help an underserved community, a lot of times if you're doing investments, you might trigger something where people are pushed out, right? And instead of helping them, then you're starting kicking them out, right? It's but a data center doesn't do that. It just stays there and it's inert. It doesn't attract things, right? So that's the best part. So anyway, going back to the Mono Lake after my thing, we actually are setting up. OCP is setting up a lab that you'll be able to play with them. So if you wanted to have an access to a Mono Lake, we are actually contributing Mono Lakes, leopards, Wedge 100s, which is another thing that comes from Facebook for open networking. There's a whole slew of things, Delta Lakes. So, you know, what's exciting is that it's happening. Open infrastructure is happening. And I think that is exciting to me because we can now start leveraging, building things more open. And if we start combining the open source ports of hardware and with the open source, we're really building a whole new family or direction of openness with specifications. A lot of time we talk about our values in open source from a software perspective, but we never think about the hardware, right? A lot of times I put so much talks at the KubeCon, say, okay, you know, you're using killing all this carbon stuff, and every time I say, well, it's Kubernetes, we don't care about the hardware. But you do have to care about the hardware because the hardware is generating carbon. And you can't sit there with your, whether it's Google Cloud or whatever it is, you should actually think about your values and think, are we using that hardware properly? Instead of the latest, can we get a circular economy? So, and now we're actually getting circular economy that could meet people's needs, at least even from a hyperscaler perspective. So that's something I'm really, 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 really passionate about. So I've come to the end of my talk. I have decided to show you all the pictures of my cats because, you did get one dog, but I didn't get a chance to get a dog in there. ahead of times. But thank you for spending 45 minutes with me. Or the talk is 1 hour, but I hope you enjoyed listening and maybe hopefully you feel impassioned to help out in open hardware. And this is me. And if you're interested in that startup, or if you want to know more about the open hardware, I'm more than happy to connect, provide information, anything else. I will say you need to speak up. I have some hearing issues, so if I don't hear you, please don't be offended or make you repeat. So, thank you.